Okay, in this video, we're going to be solving linear inequalities. With the inequalities, there's a little background I'd like to give you that I think helps my students. And again, please attend your instructor's lectures so that you will, be used to their methods as well. And hopefully mine as a secondary can help. First of all, I referred to these inequalities as open inequalities, and we denote them with parentheses or open circles. I referred to these inequalities as closed because they contain the equal sign. We're going to denote them with brackets and solid circles. The only exceptions to those two symbols, the only, symbols that receive an exception to that would be negative infinity and infinity. Always use parentheses. All right, once you've got those notes, you've got everything you need. Now, when you have something that says x is less than 1, here's what the inequality looks like. The interval notation version of that comes from you graphing it. And I'm going to actually show you, I think one of the best ways to graph this is, first of all, the only number you really need on the number line is 1. So my number lines are going to be a little bit different than you're seeing here, but we're going to use this one. I go to the 1, and because the open inequality is on, is the only one I see in that final answer, I'm going to put an open circle on the 1. Now, if you'll always solve for the x on the left-hand side, he'll tell you which direction to go. It points to the left. Now, after a little while, you'll actually know how to read it. X is smaller than, see how the smaller side is to the x? X is smaller than, x is less than 1, so it's going to go to the left. The interval notation version of that is what you get when you read the answer from left to right. This number all the way out to the left on the number line is an infinity, a negative infinity. And all the way out to the right would be a positive infinity. What your job is with interval notation is to read it like you read an English sentence from left to right. It starts at negative infinity and it goes all the way to 1. Infinities have to close with a parentheses, and the 1 where the shading stops also closes with a parentheses, but for a different reason, because of the open circle. Let's look at this next one. X is less than or equal to 1. It's less than 1, so same as before, or equal to. So you have to include the equality in there. 1. Now, I draw it in order to be able to write the interval notation. So this time, again, the only number I really care about is 1. There's a solid circle this time on the 1 because of the closed inequality. And again, if you always solve for the x on the left, he's going to point the direction you need to shade. Or you can read it. X is less than or equal to 1. Where is it smaller? To the left. So again, you read it you read it the way you read an English sentence from left to right. The shading starts at negative infinity and it goes all the way up to 1. The infinity part gets a parentheses because infinity and negative infinity only use parentheses. The 1, however, has a solid circle on it, so we'll close him with a bracket. Let's go the other direction. X is greater than. Put the larger side pointing him. X is bigger, so this time the larger side is toward the x. X is greater than 1. And again, because it's an open inequality, I'm going to use an open circle. And x is greater than 1 means it's going to go to the right because that's where the numbers get bigger. When you're writing the answer down in interval notation, you read it the same way you read English. I read it from left to right, and it wants you to describe the shaded part. The shaded part starts at 1 and goes all the way out to infinity. Infinity gets a parentheses because that's the rule. The 1 gets a parentheses because of the open circle. And one more before we jump into some answers that we get to write. X is greater than or equal to. X is, and there's greater than, or equal to 1. And again, go to the 1. Because of the closed inequality, I know it's going to use a closed circle. And it goes to the right. Why? Because x is greater than or equal to 1. Greater than 1 means everything to the right. That's where numbers get greater. Now read the answer on the number line as you go from left to right. The shading starts at 1 and goes all the way out to positive infinity. Positive infinity gets a parentheses because that's the rule. And the 1 gets a bracket because of the closed circle, because of the closed inequality. Let's look at some examples. Write the following inequalities in interval notation and sketch the graph. And actually, that's backwards. You should always graph first and then write the interval notation. Our goal is going to be the same as we were, as in solving our linear equations. Get the x all by itself on the left. That's to your advantage. If you get the x all by itself on the left, then all you have to do is find -2 on the number line. In fact, that is the only number I use on my number line. Now, because of the open inequality, I know there's going to be an open circle there. And then you read it. X is smaller than -2. Or if you can't read it, if you'll always get the x on the left-hand side, he's going to point the direction you're going to shade, and he says go that way. After a while, you just automatically will know how to read them. You must either read them or always solve for the x on the left-hand side if you want it to help you a little bit. And the interval notation is the shading as you read it from left to right, the way you read an English sentence. The shading starts at -infinity and goes all the way to -2. The infinity gets a parentheses, and because of the open circle, the -2 gets a parentheses. And there are my 2 answers. All right, x is greater than or equal to 3. Again, start with the 3 on the number line. That's the only one I care about. We know where 0, 1, and 2 are, but I don't need them. Give yourself a solid circle on the 3. Why? Because there's a closed inequality there. And x is greater than or equal to 3. Well, if it's greater than 3, it's going to go to the right. If you don't notice that or you have a hard time, don't freak out. Get the x all by itself on the left-hand side, and the inequality will also help you by pointing that direction. Kind of neat. It's a double check, isn't it? Now write the answer down, but read it the way you read English from left to right. The shading starts, oops, that's not right, is it? The shading starts at 3 and goes all the way out to infinity. The infinity gets a parentheses, but this time, because of the solid circle, the 3 gets a bracket. Let's keep going. X is greater than -5/2. And again, that's the only number I need. And again, if you have a hard time locating that, convert it to a mixed number. It would be -2.5 or -2.5 if you have a number line that's pre-numbered for you. Otherwise, if you're building your own number line, that's the only number you're interested in. Because of the open inequality, I know it's going to use an open circle. X is greater than that, so I know it's going to go to the right. Or solve for the x on the left every single time, and he will point to the right and tell you that's where you need to shade. Now, as I read the answer from left to right, like you read an English sentence, because that's how you read math graphs, the shading starts at -5/2 and goes all the way to infinity. Close the infinity with a parentheses, and the -5/2 also with a parentheses because of the open circle. And number 4, x is less than or equal to 4/3. Find the 4/3 on your number line. Because of the closed inequality, I know it's going to use a solid circle. Now, x is less than or equal to 4/3. Well, less than is going to be to the left because that's where the numbers get smaller. But if you have a hard time reading it, always get the x on the left, and he's going to point. He's going to say, go left. Nice double check. Now, write the answer down. And again, you're reading it from left to right the way you read an English sentence. It starts at -infinity and goes all the way to 4/3. -infinity gets a parentheses. That's the rule. 4/3, because of the solid circle, will get a bracket. All right. On these next ones, we're going to look at some, statements and determine which ones are true and which ones are not true. Okay, and actually, we're looking to see which ones are always true and which ones are not always true. If you know that, since 2 is less than 3, and I don't think anybody will disagree with that, when you add something to both sides, so let's say we added a 2, Let's make x a little 2. That's going to make it 4 is less than 5. That's still true, isn't it? What if I added a 12 to both sides? We're going to get 14 is less than 15. That is always going to be true, isn't it? Let's see if subtraction works that way. I'm going to start by subtracting a 2. It's the same statement, but this time 2 minus x and 3 minus x are being compared. Is 2 minus x always going to be less than 3 minus x? Let's see. 2 minus 2 will be 0, which is less than 3 minus 2, which is 1. Let's try 12. 2 minus 12 is going to be negative 10, and 3 minus 12 is going to be negative 9. Now, even though you're thinking, wait a minute, negative 10 is not smaller than negative 9, remember the number line. On the negatives, if you have negative 9, it's going to go negative 10, then negative 11. Which one is smaller? The one further to the left. So that one is also always going to be true. Now let's try multiplication and division and see which ones of these are true or false. Since 2 is less than 3, then 2x is less than 3, is less than 3x. Okay, let's see if it's true. And I'm going to use my little trick. I'm just going to plug a 2 in for each of the x's. 2 times 2 is 4. That's going to be less than 3 times 2, which is 6. Okay. Let's try a negative 2. 2 times negative 2 is negative 4. And 3 times negative 2 is negative 6. Okay, this one worked, but this one does not. If I look at my number line, negative 6, negative 5, negative 4. Negative 4 is not smaller than negative 6. It's further to the right, which that's where the bigger numbers are, right? So this one is not true. So this one is not always true. And my tip for that is try a positive and a negative anytime you're dealing with multiplication and division. In fact, I'm going to go straight to the negative 1 as my plug-in for this next one because I'm getting suspicious and they're related that way. If this one says since 2 is less than 4, then 2 over x should be less than 4 over x. Let's try it. I'm going to plug a negative 1 in for x. So we have 2 over negative 1 is less than 4 over negative 1. That's negative 2 has to be less than negative 4. And again, check them out on the number line. Negative 2, negative 3, negative 4. Remember, the larger numbers are further to the right. So negative 2 is definitely not less than negative 4. That's not true. So this one is also not always true. On our next video, we'll look at some actual problems.